So I wanted to show you a really quick demo of what can be done with terrain models using modern graphics engines. In this particular case, I'm using Houdini. And I've imported a digital terrain model of a LiDAR scan performed in the northwest of England. It's got 1 meter resolution, so it's a fairly highly resolved model. You can see if we zoom in, we can even see animal trails on the hillsides. And this will show up when we put some masks on top of this landscape. So first up, I wanted to show you a bit. I'm going to show four cases that all display some kind of solution to problems that you've been having. One of them being, let's see, rainfall simulations. I'm going to reduce the rain amount because this looks a bit too messy. And this actually has to redo the whole simulation process while I speak, and it usually takes about 20 seconds or so, but you can take the red color as a probable direction of water traveling across this landscape. This could be outputted as a PNG file, or as a PNG file, and just imported in any program and displayed it on top of a terrain model. We can also filter this based on height if we want to. So that's useful, I think. It looks absolutely mind-blowing when you output it as a two-dimensional file, all of these networks spreading out. I also want to show smoothing, which is maybe less exciting, but also very useful. This is applying a Gaussian blurring function across the landscape as I slide this, applying more and more of this filtering, it's useful for simple manipulations. There is also some occlusion simulations that we can do in order to indicate areas where that are less exposed to weather, I suppose, at least to heat from sunlight. So the darker red areas are areas where moisture is more likely to I suppose get trapped and not get evaporated from sun illumination. And I've also filtered this based on height as well. We can reduce this actually to get a more realistic look at the occlusion, because moisture should be trapped in the valleys. So this is something you can use as an indication of erosion probability, and I want to also show a bit on curvature as well, and that you can get really specific with this tool. So here I'm using this program to compute the range of curvature across this entire terrain model, and then I'm using that to filter out only the curvature ranges which are the sharpest. And again, we can be really specific about what it is that we want to show based on height and based on the curvature, and we're increasing the amount, or the amount of curvature in across the landscape. And you can see that increases the ridges as well. And these again would be areas that are prone to erosion, of course. Again, can be exported as a PNG and displayed on top of any other 3D model. And I think you can easily see how that could be useful, considering this program is also really useful for altering these meshes if we wanted to understand how the water would flow across the landscape. If this top, for instance, this mountain top, were to erode by a certain number of meters, then that is certainly something that you could use this program to simulate. Anyway, quick demo, something that might or may not be useful to you, but it's something that once you have some experience in these 3D engines, you can do these operations fairly quickly. Thanks.